today we are going to talk about a very special concept, and it is called a determinant. The determinant is the scalar value of a square matrix. So when we have a matrix and it is 2 by 2 or 3 by 3 and something like that, and we need to find the exact value, we use something called a determinant. Determinant, it is just like the magnitude of the vector. When you are using a polar form of a vector, you are having something called modulus. It is the value of the vector. This is another approach, but with the same idea. It is the value of a matrix, but we must have a square matrix, 2 by 2, 3 by 3, just like these two examples. When we trying to find this value, we use something called the sign rule. The sign rule that the first leading row is positive, the first element, and the next is negative, and so on. And we will start with negative for the second row, then positive, negative, positive, and so on. And this is our continuous process. This is the shape of the determinant, as if it is between absolute. It is not, of course, absolute. This is the shape of the determinant. However, in the matrix, we are using brackets. So how to differentiate between the matrix and the determinant by the shape of it, or the something which is obtaining. This is matrix, we have a bracket, and this is determinant, we have absolute. Of course, it is not absolute, it is a determinant. So to find the value, we are using the sign rule. I will choose any leading row. For example, I will choose the first row to be leading, to have the expansion, and I will start with A. So A is the first element. It will be multiplied by another separate determinant, another partial determinant, which is you will cancel the column of this element and the row of this element. What will remain? D. D will remain. It is also a determinant. It is a small determinant. It is 1 by 1. It will be obvious in here in this 3 by 3. So it will be A times the smaller determinant, which is D. This is not minus as a process, it is minus because we are going to use B, and the sign of B is negative. The sign of B is negative. So it will be B times, I will cancel the row of the B and the column of the B. It will remain C. Don't mention this sign anymore. This sign is related to the leading row, which is using the expansion only, which is A and B. So C and D is nothing. So it will be A times D minus B times, I will cancel the row and the column, so it will be B times C. So you can conclude that it is this diagonal minus this diagonal, AD minus BC. For example, if I have a determinant 1, 5, 4, negative 9, I need to find the value. I will just multiply 1 by negative 9 minus 4 times 5. Of course, I have 2 negative. This is the negative of the 9. Don't be confused. It is nothing. 1 by negative 9 minus 5 by 4. It will equals negative 29. It is so obvious in the 3 by 3. Here is the sign rule, as I mentioned. Positive, negative, positive, negative, positive, negative, positive, negative, positive. All you care about the leading row only, which will lead the expansion of this determinant, and all the other processes are neglected. So if I have a problem just like here and I need to find an expansion, and I choose the first row to be a leading row for the determinant, so 1 is positive, as you can see, 5 is negative, negative 2 is positive. Do you understand? So it is positive by negative will be negative, it is the same. If this one was negative, so negative times negative will be positive. You can conclude it easily. So the leading element here is 1, and it will have its own partial determinant. Then I will move to 5, although it is positive here as a value, but according to the sign rule, it will be negative. So it is negative 5 in a separate determinant, and the last one is negative 2. It should be positive, but the problem itself is negative. So I will cancel for the 1, I will cancel this column and this row, and what will remain? It will remain 0, 6, 9, 5. Here is the value. Then negative 5, I will cancel this column and this row. What will remain? 3, 6, 4, 5, and of course you can include the others. This is the determinant. Of course, it has its own properties, just like just same as the matrix, and we will find it right now. The first property is called the common factor. If we are using a matrix, the common factor is being taken from all of the elements. However, in the determinant, we are taking a common factor from only one row or one column. One row, any row or any column if exists. Just like this one, the first row is 4 and 8. Of course, it is divisible by 4, so I can take 4 as a common factor. Of course, you can take any number as a common factor, but it will lead to fractions. Of course, you can put fractions, negative decimal numbers, roots, even any non-numbers like sine theta, cosine theta, I, whatever you need to put, you just put it inside the determinant. Okay, can I multiply a number by the determinant? Of course you can, but you must pay the price. For example, this problem, it is the same as this problem. 4875, if you need to multiply by 2 for any row or any column, as I mentioned, for not all of them, you will choose one to be multiplied by. So I choose the second row to be multiplied by 2. So you need to pay the price. The price is to put half outside. So it is half times this one became, I'm sorry, I choose to multiply the first column by 2. The first column by 2. So 4 will be 8, 7 will be 14, and half is outside. So of course, I mentioned that I can take 8 from the first row as a common factor. So it will be 8 over 2. It will be 4 times 1, 1, 14, 5. Mr. Sherif, do you think that this one, it is the same as this one? Yes, in magnitude it is the same. In the shape it is not, and the shape is nothing. We all cares about the value. Of course, determinant, it is about the value. And you can make sure by find the answer. If you multiply 4 by 5, it is 20. 20 minus 56, it will be negative 36. Okay, everyone, and this is the value, negative 36, but with from another way. Okay, everyone, let's move ahead to another property. We can exchange 2 rows or 2 columns and pay the price for it to put negative. The determinant will be the same value but with a negative sign. For example, the same as my first problem, 4875, I can exchange these 2 rows instead of each other. So the first row will be the second row, the second will be first, and it is the same value but with negative. Of course, you can conclude it easily because 20 minus 56, it is the same as negative times 56 minus 20. So if you exchange 2 rows or 2 columns, just put negative outside the determinant or multiply it with negative. However, if you remember the transpose, it is for free. You can make a transpose and it is the same value. If you remember, the transpose is to make the first row to become the first column, the second row to become the second column, and it is the same because 4 times 5 minus 8 times 7, it is the same here, 4 times 5 minus 8 times 7. Let's move on. We have inside operations, and it is very useful, and I think this is the most important point of this video. I mentioned that you need to pay the price. I cannot pay for anything, and it may be for free if and only if you multiply any row or any column by any number and add this to another row or another column. How, mister? We will find right now. Do you see this row, the second one? If you multiply this row and stopped by 2, you need to put outside half. But however, if you multiply this row by 2 and add the result to the first row and make the value or the final result to the first row only, so this is the same. Let's see the same example which I'm talking about. This shortcut means negative R2 plus R1 means I will multiply the second row by negative 2, then add it to the first row. This is a translation. It is a translation for this statement. Multiply the second row by negative 2, then add it to the first row. So what will happen? Of course, the second row is the same. The multiplication is inside my mind only. The real value will be added to the first row. The thing which is multiplied by something, it is not changed. It is the same. So 7 and 5 are the same. I will multiply negative 2 by 7, then the value will be here, plus 4. Negative 2 times 5 plus 8. Okay, do you understand? And to make sure the answer is negative 36, as same as all the previous problems, because they are all the same. Of course, I will ask a question and try to answer it. Can I say that this determinant is the same as I will leave the second row the same and I will make the first row 11 instead of 4 and 13 instead of 8? This determinant is 11, 13, 7, 5. Is this right or wrong? Try to pause the video and answer. Very good, it is the same, it is right. As if I am multiplying the second row by 1. It is a number, it is any number, by 1, and add, of course, without 0. 0 is accepted, okay? So I multiplied this row by 1, then added to the first row, so the first row will have the change, so it will be 11 and 13, and this one 7, 5. When you expand, you will find it is the same as negative 36. Okay, how about the determinant all its rows are 0? Of course it is 0, because when I make the sign rule, positive, negative, positive, 0 times anything will be 0, minus 0 times anything, plus 0 times anything, all they are 0. Okay, try to find this one, why it is equal 0. It is a property. It is a property that any two rows are equal or the same, then or even two columns. Any two rows or columns are the same. The total value will be 0. Why? Try to think why. Why this is equal 0? Very good. Because it is a mix. It is a mix between the case of the 0 and the case of the inside operations, because I can multiply the third row by negative 1, then add it to the first row, so the first row will be just like this one, 0, 0, 0, and of course only one row or one column is enough if it's 0 to make all the determinant 0. Do you understand? So if two rows or two columns are equal, then the final value is 0. Okay, Mr. Sherif. why we are studying all these properties just like this for this one. If you try to be a hero and expand this determinant to make it zero, you won't reach anything because this problem is not simplified. This problem is complicated. You need to use the properties that we are talking about. If you are trying to make an expansion, positive, negative, positive, you have three variables, x, y, z. It won't be easy. And if you can this problem, another problem won't be that easy. So you need to depend on the properties of this determinant, because it will help you a lot. Okay, try to think how to make this determinant equal 0. Before we get started, do you know the relation between cosine 2x and sine square x? We studied before, huh? Try to recall your informations. Very good. Cosine 2x equal 1 minus 2 sine square x. The same as cosine 2y, 1 minus 2 sine square y. Cosine 2z, 1 minus 2 sine square z. Very good. So all you have to do, and this is the solution, all you have to do is to multiply the third column by -2 and don't pay for it. It is for free because you will add to the first column. So this is the answer. 1 minus 2 sine square x minus 1 minus 2 sine square y, 1 minus 2 sine square z. So this will be cosine x, cosine 2x, cosine 2y, cosine 2z, just as same as the second column. So the value will equal 0. Okay, another problem. Prove that this determinant is the same as this determinant. Of course, if you expand, if you don't use the properties of the what we said, it will be very hard for you because we have many variables, and you will have to deal with both sides. You will have to deal with the left hand side and to have a final value, and the left hand side to have a final value, and compare this value together. However, if you use the properties of the determinant, you won't find any problems. Okay, how to do it? Okay, Mr. Sharif, I can see that BC, it needs A, and to be ABC, AC needs B, AB needs C to be ABC. Do you understand? And this is the solution. I will multiply the first column by A, the second column by B, the third column by C, and you need to have for it to pay for it. So I will pay the price outside. 1 over A, 1 over B, 1 over C. So this one is ABC, this one ABC, this one ABC. I can take ABC from the third row common factor. It is awesome, right? You think that it is very beautiful. It is very beautiful system. When you take the common factor from the third row, you will find ABC over ABC. It will be cancelled, and it will be just like this one: ABC, ABC, A square, B square, C square, 1, 1, 1. But this is not the same as this one, so you will need to transpose, and transpose is for free. You will find it is the same this one. Okay, the last property today is called the addition rule. The addition rule. And of course, also we have another one. This is before the last one, addition rule. If you need to add two determinants together, you need to make two rows or two columns the same. You need to leave two the same. So this one is available. Determinant is not like the matrix. You just add 1 plus 1, it will equals 2. No, no, no. It is not right. Just to make two rows or two columns the same and add in between. For this one, the first row is the same first row for this determinant, and the third row is the same third row. So the answer must be the same for the first and the third, and just add which is between. So if you need to add two determinants together, you need to make two rows or two columns the same. This is a condition. It's a very important condition. Without this condition, it is not available. So 1 plus 5 equals 6, 7 plus 6 equals 13, 0 plus negative 2 equals negative 2, and the first row and the third row is the same. The last form called the triangular form, and it is very useful if you have three zeros in this place or in this place. So the main diagonal will be multiplied by each other, so the answer will be 5 times 3 times negative 8, and it is the same as if the zeros are here. Triangular came from the shape of the zero form a triangle. So they called it the triangle form or a triangular form. If I have three zeros in this place or in this place, just multiply this diagonal together. And this is finished for today. And we will have applications in the next video. See you soon.